We are doing geometric progression. Let us do some more question based on geometric progression. So question number 1, find four numbers forming a GP in which the third term is greater than the first by 9 and the second term is greater than the fourth by 18. So we have the relation, the third term T3 is greater than the first term by 9, and if we want to take these equal, then first term is already greater than first term by 9, so we have to add 9 in term 1 to make them equal. Again, the second term is greater than fourth by 18, so second term is already 18 is already greater than 4 by 18, so to make them equal we have to add 18 in the fourth term. So we have the two equation now. First is T3 is equal to T1 plus 9 and second is equal to T4 plus 18 according to given conditions. So now let the GP is AR square, AR square, AR cube are the four numbers in GP. So what is T3? T3 is AR square and T1 is A is equal to 9. Put the values T square and T here you have, इसको solve करेंगे तो we have AR square minus A as 9. So take A common, you have R square minus 1 is equal to 9. Take this as equation number 3. Again, using this condition, put the value of T2, that is AR, T4 is AR cube plus 18. So we have AR is equal to R square minus 1, which is equal to minus 18. So by dividing 3 and 4, we have R square minus 1 divided by R square minus 1, 9 upon minus 18, this cancel with this, so we have R as minus 2. Substitute value of R in any of the equation 3 or 4. In equation, from equation 3 we will get A is equal to 4 minus 1 is equal to 9, so A is equal to 3. So we have the geometric progression as AR square and AR cube. So we have 3, put the value of A and R. So we have 3 minus 6, 12 and minus 24. Next, the sum of three numbers in AP is 15. So we have three numbers in AP whose sum is 15. If 1, 4 and 19 are added to these numbers, the resulting numbers are in GP. Find the numbers. So let the three numbers which are in AP are A minus D, A and A plus D. Sum of this is given to us as 15. So we have A minus D plus A plus D as 15. So we have this cancel with this. 3A is equal to 15. So A is equal to 5. Again, if we add 1, 4 and 19 to these numbers, they are in GP. So A minus D plus 1, A plus 4 and A plus D plus 19, then they are in GP. If they are in GP, then common ratio should be same. Means A plus 4 divided by A minus D plus 1 is equal to A plus D plus 19 divided by A plus 4. आप इसको इससे डिवाइड करो चाहे इसको इससे डिवाइड करें, यू विल गेट द सेम कॉमन रेशो इफ दे आर इन GP. So this is the relation. When they are in GP, the common ratio should be the same. So now solve, put the value of A as 5. So we have 9, 5 plus 4 as 9, 6 minus D, 24 plus D upon 9. Solve this equation. Cross multiply, we have the equation as D square plus 18D minus 63. So by multiplying the numbers we will get 63 and by adding or subtracting we should have 18. So the number are 21 and 3. So by subtracting we will get 18 and by multiplying we will get 63. So factorize this and we will get D as 3 and minus 21. When D is 3 and A is 5, the GP is 258. The numbers are 258. And when A is 5 and D is minus 21, the numbers are 25, 26, 5 and minus 16. Again, next question. The M plus nth, MM minus nth terms of GP are P and Q respectively. show that mth term is under the root pq. So we have tm plus nth term which is p, and we have tm minus nth term which is q. So write tm plus nth term, so it is a r m plus n minus 1. So this is equal to p. Again we have the qth term, t minus mth term which is q. So it is a r m minus n minus 1 which is equal to q. So now dividing, this is 3 and 4. Now dividing 3 and 4, we will get r to the power 2n as p upon q. So we have r as p by q raised to power 1 by 2n. We have mth term. What we want to find? We want to find the mth term. So mth term is given to us as, is given by a r m minus 1. But we have value of r as this. So let us multiply this with r to the power, multiply and divide with r to the power n. So we have m plus n minus 1. This is the first term and this is the second term. So we have, what is value of a r? M plus n minus 1. So value of m plus n minus 1 is p. So put the value of p here. We have p and here is 1 upon r to the power n. So r is p by q to the power 1 upon 2n. So what is 1 by r? It is q by p to the power 1 by 2n. So n se n cancel. So it is under the root q upon under the root p. So it is 1 minus 1 by 2. So it is root p root q. Clear? P upon root p is root p and this is root q. So it is root p q. If a, b, c, d are in GP, then prove that a square plus b square plus c square and c square plus d square are also in GP. Let a, b, c, d are in GP. If they are in GP, then first term is a, second b is equal to ar, and c is equal to ar square, and d is equal to ar cube. Let us put the value of a and b here. A square plus b square is equal to a square plus a square into r square. Value of b is ar. Put a square common, so we have 1 plus r square. Again find value of b square plus c square. So we have a square r square and a square r4. Take a square r square common, so we have 1 plus r square. Again find value of c square plus d square, so we have this value. If these three terms are also in GP, then common ratio should be same in each case. So let us now divide this by this. So divide b square plus c square by a square. So we have the common ratio as r square. This cancel with this cancel with this. Again dividing c square plus d square by b square plus d square. Isko divide karoge. So you will get this cancel with this cancel with this. This is r square. This cancel. So we have again the common ratio as r square. Since the common ratio is same, therefore we have these terms are also in GP. Clear? Again, next question. If a, b, c, d are in GP, then prove that a to the power n plus b to the power n, b to the power n plus c to the power n, c to the power n plus d to the power n are also in GP. The same question, let a be the first term, b be ar, c is ar square, third term, and d is ar cube. Now find value of a to the power n plus b to the power n, or you can simply, if they are in GP, if the common ratio is same, you can do this like also. So what you want to show that common ratio is same in each case. So let us divide this with this and divide this with this. So we have b square. This is in GP if these ratios are equal to each other, that is bn plus c, b to the power n plus c to the power n divided by a to the power n plus b to the power n is equal to c to the power n plus d to the power n upon b to the power n plus c to the power n. Now put the value of b and c here, and after solving you will get value of r is rn. Common ratio in this case is also rn and this case is also rn. So therefore they are in GP. Next is the 5th, 8th, 11th term of GP are P, Q and S respectively. Show that Q square is equal to PS. So what we have given, the 5th term is P, the 8th term is Q and the 11th term is S. So let T5 as P, T8 as Q, T11 as S. So T5 is AR to the power 4, which is P. T8 is AR to the power 7, which is Q. T11 is AR to the power 10, which is S. Clear? So let us find relation, multiply P into S, that is multiply 5th and 11th. जो हमें दिया हुआ है उसी को देखते हुए हम प्रूव करेंगे. So let us now multiply first and the third. So we have P into S is equal to A4 into A to the power 10. Bases are same in multiplication, powers will get add. So A to the power 1 plus A to the power 1 is A to the power 2. R to the power 4 plus into R to the power 10 is R to the power 14. So we have R square into R to the power 14 is P into S. Let us now check what is A square into R to the power 14. We have A into R to the power 7 is Q square. If we square this, what will we get? We get A square into R to the power 14 is Q square. So this squaring the second term, we will get this. So these from 4 and 5, the left hand side is equal. So therefore right hand side should be equal. So we have the relation Q square is equal to PS. Next is the sum of three numbers which are consecutive terms of an AP is 21. If the second number is reduced by 1 while the third is increased by 1, the three terms are in now GP. Find these numbers. So we have the three numbers which are in AP. So let the three numbers are A minus D, A and A plus D. Their sum is given to us as 21. So let us add these numbers. So we have A minus D plus A plus A plus D. So we have 3D is equal to 21 and A is equal to 7. If the second number is reduced by 1, that is if A is reduced by 1 and the third is increased by 1, so A plus D plus 1 and the first remain as it is. Now the resulting terms are in GP. If the resulting terms are in GP, then common ratio should be same. That is, if we divide A minus 1 with A minus D and if we divide with A plus D plus 1 with A minus 1, we will get the same ratio, same number. So this should be equal. So we have the relation A minus D upon A minus 1 upon A minus D, dividing A minus 1 with A minus D should be equal to when we divide A plus D plus 1 with A minus 1. That is, common ratio should be the same if they are in GP. Put the value of A, so it is 7 minus 1, 7 minus D, 7 plus D plus 1 and 7 minus 1. So we have 6 upon 7 minus D, 8 plus D upon 6. Now cross multiply, you will get the equation, that is D square plus D minus 20. So on multiplying we will get 20 and on addition or subtracting we will get 1. So what are the numbers? Numbers are 4 and 5. Factorize and you will get D as 4 and minus 5. When the D is 4, the number are 7 minus 4. 7 and 7 plus 4, so the number are 3, 7, 11, and when D is minus 5, the number should be 7 minus minus 5, 7 and 7 minus 5. So 12, 7 and 2. Next question. If Pth, Qth and Rth term of GP are themselves in GP. So what is given to you? Pth, Qth and Rth term of GP are in GP. Then prove that PQ are in AP. So let us now write Pth, Qth and Rth term of GP. So we have Pth term as A into P to the power R to the power P minus 1. TQ as AR to the power Q minus 1. And TR as AR to the power. Now let us take this common ratio as capital R. So take this common ratio as capital R. Here it is capital R and capital R. If these are in GP, then what will happen? The common ratio will remain the same. That is, by dividing AR to the power Q minus 1 upon AR to the power P minus 1, AR to the power R minus 1 divided by AR to the power Q minus 1, you will get the same common ratio. You will get the same number. Clear? So, A cancel with A, cancel with A. So, what will you get? You will get capital R. This is capital R. Instead of small r, this is capital R. So, we have Q plus Q. It is 2Q minus 2. And here you have r into r to the power p minus 1 into r minus 1. In subtraction, cross multiply, you can cross multiply. So it is it is r q minus 1 into r q minus 1. So it is r to the power 2q minus 2. Because in multiplication, bases are same, powers will get add. Here also cross multiply, r into p minus 1. Here r is capital, and r into r minus 1. Clear? So you have r, bases are same. In multiplication, powers will get multiply and will get add. So we have p plus r minus 2. So we have p plus r minus 2 here. So by comparing the powers, you will get power of this as 2q minus 2 and power of this as p plus r minus 2. So minus 2 will get cancelled. So we have q is equal to p plus r by 2. So therefore they are in AP. If we have q as arithmetic mean between p and r, then the three numbers should be in AP. If PQ are in AP and XYZ are in GP, then prove that this is equal to 1. Again, PQ are in AP, three numbers are in AP, then the middle one is the arithmetic mean between the extreme ones. So we have q is equal to p plus r by 2, that is 2q is equal to p plus r. Now let us take the XYZ, they are in GP. If they are in GP, then common ratio should be the same. That is, if we divide y with x, we will get the same number when you divide z with y. So we have y upon x is equal to z upon y. So by cross multiply, you will get y square is equal to xz. So let us now take this left hand side of this equation and put the value of xyz here. Xyz, put the value of q. Q is p plus r upon 2. So you have this x as x to the power p minus r by 2. Y, put the value of y. Y is xz. So y square is, what is y as? Y as xz to the power 1 by 2. Clear? Put the value of xz to the power 1 by 2. So what will you get? You will get xz to the power r minus p by 2. So ये r minus p divided by 2 हो जाएगा. यहाँ पे आपने y की वैल्यू डालनी है. y is z xz to the power 1 by 2. Again this as it is. So these are in multiplication. So power of this get added. So we will get this. Powers of this get add. जब आप add करोगे तो r cancel with r, p cancel with this. So you will get x to the power 0. Let us now combine this z with z. So what we have r minus p by 2, p minus q, plus करना है इसमें. So take the LCM, solve. So you will get, put the value of q here. Q is p plus r by 2 and combine this whole. When you combine this whole, you will get the value of z as 0. This is p minus r by 2. So value of z as 0. So answer is x to the power 0, z to the power 0, anything raised to power 0 is 1. Next question, if ABC are in AP, we have given that they are in AP, BCA are in GP, then prove that they are in AP. If they are in AP, ABC are in AP, then we have B as the mean of the extreme numbers, that is A plus C by 2 is equal to B, or you can say 2B is equal to A plus C, though this as number 1. Again BCA are in GP, so C upon B should be equal to A upon C. So C square is equal to AB, or you can say BA when they are in GP. So this as number 2. Now we want to prove that they are in AP. They are in AP if this number is arithmetic mean between these two numbers. So we have this 1 by C plus 1 by B divided by 2 is equal to 1 by A, और ये 2 को अगर हम यहाँ पे ले ले तो it is 2 upon A is equal to 1 upon C plus 1 by B. If these both are equal, then the numbers are in AP. So let us now calculate the right hand side of this expression. So this right hand side is, take LCM. B plus C upon BC. Now put value of B from this equation. B is C square by A into this. So we have B as C square by A plus C square by A into C. So this you have C cancel with this C common. Here you have C by A plus 1. Clear? And you have C by A plus 1. Take the LCM now. So it is C plus A. It is C plus A upon C square. Okay? And C plus A is 2 times B. By using 1, first equation was 2B is equal to A plus C, or you can say C plus A. So you have 2B upon C square. And we have C square is equal to BA. So therefore what is B upon C square? B upon C square is 1 by A. Clear? So you have B upon C square as 1 by A. So what you get? You will get 2 upon A, which is equal to left hand side of this equation. That is 2 by A is equal to 2 by A, which is true. So therefore 1 by A, 1 by B, 1 by C are in AP. So this is all about today's lecture. So thank you for watching the video.